to study heating effect of electric current. Heating effect of electric current. As you know that when current is continuously flowing, there will be heat produced in the conductor, or if bulb is glowing continuously, it will be heated after some time. So basically we are going to study heating effect of electric current. As you know that potential difference, potential is what I defined it for. Potential is defined as work done per unit charge. Work done per unit charge is called potential difference, or you can call it potential. Is that clear, everyone?
Yes, sir.
Work done, potential, how I defined potential in the initial in the beginning of this chapter. Work done per unit charge. Per unit charge, that is called potential. Now we are going to define power. Power is basically power P will be equal to before this I am going to write another formula in the, with the help of this formula. W is equal to V into Q. Can I write this? Potential is defined as work done per unit charge. So with the help of this formula, can I write W is equal to V into Q? Can I write it or not?
Yes, sir.
And from class 9th, you have studied in work power energy. Have you studied work power energy? Power is equal to work done per unit time. Work done per unit time. That means power is work done upon time. Power is work done per unit time. So from here, I can easily write power is equal to W upon T. And you can see W is equal to V by Q, V into Q. So I'm going to put this formula. P is equal to V into Q by T. Can I write this? This is very easy. Potential we have already studied in the beginning of this chapter. Potential is work done per unit charge. So I wrote it in mathematical equation V is equal to W by Q. With the help of this equation, W will be work done will be equal to V into Q. This W is work done, Q is charge, and V is potential. Now we already know that from class 9th you have studied in class 9th of the chapter work power energy. Power is work done per unit time or energy per unit time. So you can see P is equal to W by T, and W has a formula from this chapter, V into Q. So I just put the value of W, and P is equal to VQ upon T. Is that clear, everyone?
Yes, sir.
Yes, sir.
Now see, you already studied in this chapter from the beginning. I is equal to Q by T. You have studied about this. I is equal to Q by T. So P is equal to, I am going to write it, V into I. Can I write this? At the place of Q by T, can I write V? Because in the beginning of the chapter, the definition of current is basically charge per unit time. I is equal to Q by T. So at the place of Q by T, I can write I. So power is equal to V into I. Now we are going to talk about heat. So heating effect, I'm going to write heat produced, heat, that means H, produced in time T. In time T, whatever is the time for heating, H will be equal to P into T. H will be equal to P into T, and you know that P is equal to VI. So the main formula of H will be equal to V into I into T. I'm going to explain it again. It's very easy. You will easily get it. H will be equal to V into I into T. How this formula comes? So the formula is very easy. This heat is basically heat energy. We are talking about heat energy. I'm going to explain it from the beginning. First, you write it and let me know if you are finished with this. This is very easy. Please write it. Sarah, are you there? Am I audible to you?
Yes, sir.
So why were you absent yesterday? Sorry, in the previous class. Have you
Uh,
watched the lecture?
what's it?
No, have you watched the previous lecture?
I was actually very busy at that time, like after coming from school.
Okay, okay. So basically, in the previous class, we have done some questions. So please let me know if you are done with this. Hamna, Abdullah, Sarah, and everyone, your paper, upcoming paper will be subjective or objective, multiple choice question or subjective.
Our all exams will be subjective now.
Subjective. Okay, so I will give the assignment and that will be subjective too. Harsha, are you done with this?
Yes, sir.
Okay, everyone done with this?
Yes, sir. Can you scroll?
Okay, okay. Yes, wait a minute. Very good. Okay, okay, Abdullah. Okay, let me know if you are finished with this. So the basically here the formula is uh, roaming round and round. You can see I'm going to explain it again. It will be very easy. We use initially the formula of power. After that, you will see that we will use the formula of energy in terms of power.
Finish.
Okay, everyone finished. So I'm going to explain it again. Please concentrate here. So we are going to learn heating effect of electric current. As we know that when a current is continuously flowing, the conductor or the you can see the bulb is heating slowly. That's why we are talking about heating effect or heat energy. We are talking about heat energy. So with heat energy, before going to heat energy H, we are we will talk about potential. You know that potential in the beginning after electric current, I have taught you the potential. Potential is work done per unit charge. So in mathematical equation, I can write V is equal to W by Q. This V is potential, W is work done, and Q is charge. So I can also write W is equal to V into Q. Is that clear, everyone? Now see, power has two formula in class 11, sorry, in class 9, that is W by T, or it is also P is equal to E by T, that is energy. Energy per unit time or work done per unit time is the formula of power. So I'm going to use this formula here. P is equal to W by T, and you can see the value of W is V into Q. Since we are talking about we are talking in terms of current, we are studying current chapter. That's why we are going to put the value of W in terms of charge and potential difference. So P will be equal to VQ by T. T comes from the formula of power in denominator. Now we also know that I is equal to Q by T. I is equal to Q by T. So I just put I is equal to Q by T. At the place of Q by T, I just put I. So the new formula of power is P is equal to V into I. Now see, heat produced in time T. You already know that heat, that we are talking about energy. You know that P is equal to energy. We are talking about energy E or heat energy or kinetic energy, whatever is the energy. Since here we are talking about energy, so H by T. So heat energy H will be equal to P into T. P into T. P into T. You can see here I wrote it P into T, and you know that power has a formula that we derived. P is equal to VI. So we got a formula H is equal to V into I into T. H is equal to V into I into T. So this is the formula, basic formula of heating effect of electric current. Another formula for this, applying Ohm's law, you know that V is equal to IR. V is equal to IR. So I'm going to put the value of V here. So it will be H is equal to, at the place of V, I'm writing IR into I into T. So IH is equal to I into I, that will be I square R into T. So heating effect of electric current has two formula. The first one is H is equal to VIT, and the another formula H is equal to I square RT. This formula is very important. This three formula is very important. Please write the second form of heating effect of electric current. Please write it and let me know. Please let me know if you are done with this.
Answer.
Done everyone? Hamna, Sarah?
Yes, sir.
Okay. I'm going to give you a question on this topic. I'm going to give you a question on this topic. An electric item consumes energy at
Sir,
yes,
I have a test on Wednesday for physics,
which chapter?
electricity only.
Okay, the whole chapter, right?
Yeah.
Okay, we will easily complete this chapter almost 99% today. Okay. When heating is at, it's a unit test, right? Maximum rate and 360 watt when the heating is at the minimum. The voltage is 220 volt. What are the current and the resistance? In each case. In each case. Please do this first. Everyone done with this? Harsha, Abdullah.
Doing, sir.
Okay,
Doing
very good.
Sir, can you explain?
Yes, yes. Everyone concentrate here. Two questions are there. An electric iron consumes energy at a rate of 840 when heating is at maximum. Just take it 840 in A part and 360 watt in B part. And there is a voltage that is given 220 volt. So I'm going to split it into two parts. A part, the power is 840 watt and potential is 220 volt. What the question asks about what is the current? You know that P is equal to V into I. So I will be equal to P upon V. So what is the power? Power is 840 and potential is 220. So you can see the current has a value 11 and this will be 42 times. Now, if you are going to divide it, it will be almost 3.8 ampere. So what are the current and resistance in each case? The first case, the current is 3.8 ampere and we need to calculate resistance also. You also know that from Ohm's law, by Ohm's law, V is equal to IR. Since potential is given and we just calculated, so R will be equal to V upon I. And what is V? V is potential, that is 220 and I is 3.8. So if you are going to divide it, it will be almost 57.6 ohm. This is the first answer. Can you do the second part? Harsha, Abdullah, Sarah,
Yes,
and
sir.
Hamza? Okay, please do it and let me know the answer. Done, everyone?
no, sir.
Okay, please do it. I'm waiting for your answer. If you have any doubt, ask me. So I'm going to explain it
Sir,
in the answer. Yes,
the first one is finding the current and second is finding resistance, right?
yes, with the help of finding resistance with the help of Ohm's law.
I found current.
Yeah. So you can see I'm going to explain the B part. Power is basically 360 watt and potential is given 220 watt. Now see, P is equal to V into I. So I will be equal to P upon V. What is the power? Power is 360 and volume volt is potential difference is this. Now you can see 2 18 is 36. This is 11. If you are going to divide it, it will be 11 1 11 and then 7 left. And again 11 6 66. So it will be 1.64 ampere. And if you are going to find the resistance, you can see from Ohm's law, by applying Ohm's law, V is equal to IR, we can calculate resistance that will be V upon I. V is given as 220 volt and I is 1.64. And if you are going to divide it, it will be 134.15 ohm. Abdullah, is that clear? Okay, please do it and let me know if you're done with this.
Sir,
Yes, yes.
for finding the resistance, I got 134.44.
4.
Yeah.
You divided 220 divided by 1.64, right?
Yeah.
So please check it. It will
Sir,
be
18 by 11 would be 1.63, right?
1.
63.
Wait a minute. I just it will be like you can see, if you are going to divide it, it will be 1.636363. So after rounding off, if I'm going to round it off, it will be 1.64.
Okay, sir.
And Sarah, if you are going to divide 220 divided by 1.64, it will be basically 134.146. If you are going to round it off, it will be 134.15, not 44. Please check your calculation.
Okay, sir.
Okay. Everyone done with this?
Yes, sir.
Okay. Wait a minute. No. Okay. So I'm going to give you another question and then the last topic of this chapter, that is power. Okay. Now see, and my video is off. Okay. So this is the question. 100 joule of heat is produced each second in a 4 ohm resistance. Find the potential difference across the resistor. Find the potential difference across the resistor. Okay. Please listen to me. Harsha, do you have previous year's question of your school? Abdullah, Sarah,
Sir, say again.
Do you have previous year's question of your school?
Question paper.
Yes, question paper of previous year's question paper. Abdullah, Harsha,
Sir,
do you
I'm
have
not
previous year's
sure.
question?
I'll check.
Okay, I'm going to no. Okay, Hamna, Sarah.
Sir, I will also check. I'm not sure.
If you get it, the previous year's question, please send it to me. I just want to see the pattern of it.
Okay, sir.
So here is the question. 100 joule of heat is produced each second in a 4 ohm resistance. Find the potential difference across resistor. We need to calculate the potential difference. That means we need to calculate. Now, what is the given heat? That is 100 joule. Our resistance is 4 ohm, and also each second, that means time is 1 second, and what we need to calculate is potential difference V. So after seeing this, we can easily calculate V. You know, you have two formula. H is equal to I square RT, and H is also equals to PV into T. These two formula we have for heat energy. Yes or no?
Yes, sir.
Okay. Now see, sorry, this is PVT, not PVT. VIT. This is VIT. So we had two formula of heating energy, heat, that H is equal to I square RT and H is equal to VIT. And we need to calculate resistor R. And now see where we can fit this given. 100 joule, this is given, R is also given, time is also given. So easily we can calculate I. And if you are going here, H is given, T is given, I is not given, V is not given. So this cannot be applied. If we have some formula, we will have, we will be given everything except one, which we need to calculate. So I am going to apply this formula for I. We can write I square will be equal to H upon RT. And we can also write I will be equal to under root of H upon RT. Can I write it or not?
Yes, sir.
Yes, sir.
Now see, H has a value 100, R has a value 4, and T has a value 1. Root 100 will be equal to 10. 4 into 1, that will be 1, and root 4 has a value 2. So we got a value 5 ampere. We got a value 5 ampere. Now we need to we don't need to calculate the value of current. We have given that you need to calculate the resistor potential difference across resistor. So if you are going to apply the formula Ohm's law, if we are going to calculate Ohm's law, by Ohm's law, you know that V is equal to IR, and I has a value 5 and R has a value 4. So it will be 20 volt. Is this easy or not? Why we didn't apply this formula? This is very important to note. We have two formula for heat energy, and the first formula is equal H is equal to I square RT, and the second formula is H is equal to V into I into T. In this formula, only I was not given, and all the components are given like H, R, T. But in this formula, we have two components and two, we can say, potential difference and current, both are not given. That's why we didn't apply this formula. We applied this formula. And by finding current, we can easily calculate the value of potential by applying Ohm's law. If you have any doubt in this, please ask.
Done, sir.
Done, everyone? Abdullah, Sarah,
Yes, sir.
Amna, and Sarah, are you done with this?
Yes, sir.
Okay. So now write a new topic, that is electric power. We have already studied about this electric power. So basically, what is electric power? See, I already have a formula from the previous topic, that is power P is equal to V into I. We derived this formula. I can show you this formula. P is equal to VI. Here you can see this is. So I'm going to write the direct formula of this, that is P is equal to VI. Now we also know that we are going to reform this formula, or I can also write P is equal to I square R, and I can also write P is equal to V square upon R. How this formula comes? So I just derived this formula, and from this formula I can write this, and from this formula I can also write this. How? So you know that V is equal to IR. So I just put the value of V, IR here. So P will be equal to, you can see at the place of V, I can write IR into I. So it will be P is equal to I square R. If you are going to see this, you know that from V is equal to IR from Ohm's law, and I will be equal to V upon R. So I am going to put the value of I here, and in this I am going to put the value here. So P will be equal to, at the place V will be like V, and I at the place of I am going to write V upon R. So with the help of Ohm's law, P is equal to V square upon R. So basically for power we have three formula. The first one is P is equal to VI. P is equal to VI. The second formula, P is equal to I square R, and the third formula for power, P is equal to V square upon R. So according to the given situation, we apply these formulas. Please write it. And everyone should know what is the unit of power. Unit of power. Can anyone tell me? Watt. Unit of power, that is watt, and denoted by W.
Sir, can you tell how to derive the third one?
This P is equal to V square upon R, right? Are
Yes,
you
sir.
asking about this? So you know that Harsha, V is equal to IR.
Yes, sir.
So see, and you also know that I is equal to V square V upon R.
Yes, sir.
So for the second formula, you can see I just put the value of V, that is IR, and for the third formula, I just put the value of I. I is equal to V upon R.
Okay, sir.
So you know that P is equal to VI. If I'm going to put the V as it is and putting the value of I, that will be V upon R. So it will be V square upon R. Okay.
Okay, sir.
Okay. Please write it and let me know. SI unit of power is watt. And now we are going to define what 1 watt. SI unit of electric power, just right. It will be more specific.
So done.
Done, everyone?
Yes, sir.
Yes, sir.
Okay. Now see, define 1 ampere, 1 watt. Define 1 watt. So basically, we have a formula, P is equal to V into I. So how we are going to define? Just see, 1 watt is defined as, write with me, power consumed by a device that carries 1 ampere of current, when operated at a potential difference of 1 watt. So I can write 1 watt will be equal to 1 volt into 1 ampere. 1 V into A. That is also known as 1 watt. So basically 1 ampere of current carries 1 ampere of current when operated at a potential difference of 1 volt. That is defined as 1 watt. Please write it. Done, everyone?
Yes, sir.
Okay. Now see, we are going to talk about commercial unit of the electric bill is the commercial unit. Commercial unit of electric energy. Commercial unit of electric energy is kilowatt hour. Kilowatt hour. This is very important to note. Commercial unit of electric energy is kilowatt hour, and 1 kilowatt hour will be equal to 1 kilowatt. That means you know that 1 kilowatt is equal to 1000 watt, and for hour it will be 60 into 60 seconds. So I'm going to divide this 1000 watt into 60 into 60. That will be equal to 36 watt second. And we can also write 1000 into 3600. Can I write it 3.6 into 246? 10 raised to the power 6.
Yeah.
Yes or no? Watt second. Watt second. And you know that power is equal to, power is the unit, what is the unit of power? And power is energy by time. So I'm going to write at the place of watt, I am going to write this is joule. Energy of unit is joule and time is second. So I'm going to write joule per second into second. So 1 kilowatt hour will be equal, second will be cancelled by second, and 1 kilowatt hour will be equal to 3.6 into 10 raised to the power 6 joule. This is the commercial unit of kilowatt hour is commercial unit of energy, commercial unit of electric energy, and that 1 kilowatt hour is equal to 3.6 into 10 raised to the power 6 joule. This is very important to note. It will be asked. Please write it.
So done.
Done, everyone?
Sir, in the second line, it is watt per second.
No. It is watt second, not per second. Okay, this is watt second, watt second, watt second. But we know that watt is basically joule per second. This watt is the unit of power is watt, because it watt is used for to give the honor of the scientist, honor to the scientist. Like kg meter per second square is the original unit of force, but we call it Newton. Okay, and this watt is used for James Watt. Okay.
Okay, sir.
Okay, please write it. Everyone done with this?
So, 1 minute.
Yes.
Okay. Okay, please do it, and then we will do question on this topic. And this chapter almost completed. In the next class, we will do commercial on questions on commercial, and then we will do for the first chapter, chemistry.
So, done.
Okay, everyone done with this?
Yes, sir.
Okay, I'm going to give you a question on this. Please apply carefully. An electric bulb is connected to a 220-volt generator. The current is 0.5 ampere. What is the power of the bulb? Very easy question. Please do it carefully.
Sir, 110 watt.
Very good. Any answer? I'm going to give you another question.
Sir, 110 watt. Sir, we just had to multiply it, right?
Yes, you just have to multiply it.
Yeah, so I got 110
10.
watt.
Very good. P is equal to, you know that P is equal to V into I, and V has a
Yeah.
value 220 and I has a value 0.5, and you can write it. I'm going to just simplify it 5 by 10, and you can see 0 will be cancelled, and 5 to the 10, 5 to the 10, 1, 11, and this is basically P, so it is watt. Is that clear, everyone? Abdullah?
Yes, sir.
Okay. So another question I'm going to introduce: an electric refrigerator. An electric refrigerator rated 400 watt operates 8 hours a day. 8 hours per day. What is the cost of energy to operate it for 30 days at rupees 3 per kilowatt hour? Please let me know if you are unable to solve it. Can you do this, Harsha? Sarah, Abdullah, and Hamna. Hamna is
So
not
trying.
there. Okay, please do it. And let me know if you are unable to solve it. Okay.
Yes, sir.
So we need to calculate for 30 days. For one day, it will be 8 hours per day, 400 watt. So you need to calculate watt hour first, then kilowatt hour. See, I'm going to explain it. See, we have power is equal to 400 watt, and it is consuming 8 hours per day. 8 hours per day. And we need to calculate for 30 days. So power will be equal to total energy consumed in 30 days would be 400 watt and 8 days per hour for 30 days, 8 hours per day for 30 days. So it will be 96,000 watt hour, which is going to be converted into kilowatt. So it will be 96 kilowatt hour. This is the total energy. Now you can see it is rupees 3 per kilowatt hour, and we have 96 kilowatt hour. So price that the cost we need to pay is 3. You can see 96 kilowatt hour into rupees 3 per kilowatt hour. That means this will be kilowatt hour. This will be per kilowatt hour. So it will be cancelled, and you can say 3 6 the 18, 3 9 the 27. So rupees 288. This will be. So we need to be pay the bill, electric bill, that is 280. If you have any doubt in this, please let me know.
So done.
Done. Any doubt?
No.